So Jennifer, we're at the age of a new way of constructing satellites in space, and Dragonfly is sort of paving the way. What is Dragonfly?
Yeah, so Dragonfly is a robotic assembly in space program. So traditionally when we build commercial communication satellites for our customers, we have to design them so that they can fit inside the rocket fairing. And that really limits where we can place things and how big our antennas can be. And what we're doing with Dragonfly is completely changing the rules of the game. The Dragonfly robotic arm is going to allow us to actually take a reflector from a different location where we don't normally put them and move it and install it once we get up on space. And what that allows us to do is to put much larger antennas in space, and that ultimately gets our customers better performance.
So is it fair to say that in the future, you won't have to complete your satellite on the ground? You'll complete part of it, and the rest of it's going to be completed in space.
That's exactly right. And we are looking at all kinds of applications in the future and looking at those applications as we design for Dragonfly. So we're really designing the system to have a lot of flexibility so we can do even more innovative things in the future. So one of the applications we're looking at is not just being able to move a reflector from one location on the satellite to another, it's actually being able to assemble a reflector in space. And NASA's going to be interested in that capability for things like future generations of space telescopes. We can actually build even bigger mirrors than we would if we just built them on the ground. And the robotic system allows us a lot of flexibility to change things out over the life of the satellite. So we may fly a satellite up with extra reflectors, and then once we're up there, our customer may decide, you know what, I want to go use a different one today, and we'll be able to swap it out once we're up there. We don't have that capability today.
So it seems to me that as these engineers are coming up from high school to college, they want to be future satellite engineers, they're going to be trained differently. So you're sort of rewriting the textbooks on how to design satellites for the future.
Absolutely, and Dragonfly is really creating the building blocks that's going to allow us to do some of the future things in space that we can't do today. So a mission to Mars, for example, is going to rely on being able to assemble things in space or even build things in space. And one of our partners on Dragonfly is a company called Tethers Unlimited that's building an additive manufacturing device that we can actually build things in space. What we can do with that on Dragonfly is create a large structure in space that we can attach our reflector to, and it improves the optics of that RF system and again gets our customers better performance. So we're already being able to show manufacturing in space, and that building block is going to allow us to expand in the future. So engineers of tomorrow are going to be able to take these blocks we're building today and completely change the game for the way we build spacecraft.